agenda. So I'll give you a quick overview on GSS, and then I'll give you an overview on the LP3, what the mounting options are for it, some of the new functions that we've added to this sensor, and then I will cover some of the software features that we also have on the sensor, and then close down with a quick summary. Okay, let's get started. So GSS, we are a designer and manufacturer of solid-state non-dispersive infrared CO2 sensors. All GSS sensors are manufactured in-house with our own LEDs and photodiodes. We have our own unique molecular beam epitaxy facility that produces our own LEDs and photodiodes. We also have some in-house R&D, so we can do some custom sensors. So if any of our standard products don't quite meet what you're after, please come and speak to us and we can see what we do. And that also allows us to do some system design and some other development expertise. So we're here to help where we can. Like I said, we have standard products and we can do standard options where it makes commercial sense. The company was established back in 2006, and we have all our production in the UK. And obviously we have patent technology for measuring CO2. Okay, looking at some of the key target applications for the LP3, these are really targeted at air quality and heating and ventilation control systems, with also some companies looking at it for horticulture, for monitoring inside greenhouses and vertical greenhouses. Some of the other areas that we look here are on this slide are food packaging, modified atmosphere packaging, obviously the transportation of fruits where you want to put the fruits into hibernation and bring it over the seas with controlled CO2 and lower temperatures. Then we have other ranges for the medical side, for incubators, for growing different cultures. And then from a human point of view, looking at breath analysis and sports science. We also have some sensors that are used in aerospace for looking at cabin air quality, the crew environment monitoring, and also the deployment of fire suppressant CO2 and cargo holds. Other ranges are used in personal safety monitors and also in leak detection. I meant to mention in the earlier slide, you saw an astronaut there in the International Space Station who was wearing a monitor for monitoring the CO2 going around the International Space Station. These are the ranges we have. The CoziR range, which looks after the ambient sensing. Both the Explorer and the Sprinter range can measure up to 5% up to 100% CO2. Today we're going to concentrate on CoziR and in particularly on the LP3. So there is quite a bit of legislation drivers for these, for indoor air quality and things. Also just now with COVID, there are some other studies going on heating and ventilation. So if you have some new legislation that's coming up in your country, please feel free to send us a link to this, and we will look at that and see if there's any additional features we can add and potential new sensors that we can bring out. That would help. Okay, looking at GSS's sensor technology, this is a picture of one of our machines that we use for growing the wafers. We use solid-state ultra-low power LED light source and photodiode. Both of these are grown in our own facility, and they're based on gallium arsenide 4-inch wafers. We grow them and we tune them to 4.2 micrometers wavelength, which is ideal for use in CO2 sensors. And you will see on the next slide how the sensor is made up. So we have a photodiode and we have an LED. The LED emits a beam, and that goes around the optical cavity that you can see in the diagram on the right, and then it's picked up on the photodiode lines. With Beer-Lambert law, the concentration of the CO2 is proportional to the absorption of the light. And as you can see in the graph below, CO2 has a very unique wavelength that it absorbs. so there's no crossover with any other gases. Okay. Some of the advantages of LEDs over incandescents: obviously they have much lower power, and the startup time to the first read is very fast. There's no need for them to heat up. Again, the energy is very low when compared to incandescent bulbs, and the lifetime, we reckon our sensors are 15 years plus. We still see this growing. Obviously, we can't tell until our sensors still been going for that longer time, so we continue to monitor sensors that we built from way back, and we can do a very fast measurement rate of up to 50 hertz. Okay. Also, with these being solid state, they're very robust, and some of our sensors have undergone avionic vibration testing, so to back that up. Let's have a look at the CoziR-LP3, which is the newest member of our LP3 family. Some of the key features: it's obviously an ambient CO2 sensor. It's designed to measure up to 1% CO2. It's ultra low power, and it's small and has a low profile form factor, and we'll cover a bit more of that in the next slide. Some of the benefits of it: it enables maintenance-free battery-powered operation. It's ideal for handheld and wearable, as we saw in the International Space Station, and it's suitable for integration with wireless internet chipsets such as LoRa and Sigfox. Some of the key specifications of it: we offer the sensor in 3 ranges: 0 to 2000 ppm for the horticultural market, 0 to 5000, which we see as the most popular for indoor air quality, and 0 to 1% if your customers have some other requirements. The time to the first reading is less than 3.5 seconds. It has either a digital UART or an I2C interface. There is the option to have analog voltage output from it, which I'll cover later. And the standard operating temperature is 0 to 50 degrees C, and the operating voltage is 3.25 to 5.5 volts. Here are some of the mounting options for the sensor. The sensor, we've listened to what customers' feedback they gave us on the LP and the LP2 with the 1 row of pins at one end. Some customers felt that it would be better with a different option to make it more stable. And also with the socket underneath it, also increased the height. So what we've done this time is we've added pinholes at the end, which are a standard low-cost 2.5 pitch. So easy to mount the pins onto. You can either mount it on top of your PCB, or you can mount it underneath your PCB. You may have a battery compartment underneath your board or on top of your board, so it makes sense to match it up with that. If you want to have the lowest profile, what we would suggest is that you put a hole in the middle of the PCB and mount the sensor halfway through it. Okay. Let's look at some of the hardware functions of the LP3. We have a power on status pin. Now, this controls the power of the actual sensor itself. If the power on pin is held low, the sensor will remain in a quiescent state, and it will be consuming less than 3 microwatts. In this state, the sensor won't respond to any commands. So to turn the sensor on, you have to set the pin to high. If you're not going to use this to power the sensor off and on, we recommend that you permanently connect it to the supply voltage. So there's no additional circuitry needed to modulate the power consumption. When it's in a quiescent state, it's close to 0. So this obviously reduces the power helps reduce power consumption for you in your power budgets. We've added an alarm output to the sensor. So this is totally programmable, so you can set the level that you want the alarm to go off when we ship the unit, it is by default it's off, so you need to write a value to it to actually set that. Once it go, and the threshold of this value can be anything from 0 up to the full scale of the sensor. So what happens when it reaches that threshold, as it outputs a digital held flag until the CO2 falls below 80% of the threshold you've set. We've done this so you don't get any hysteresis around the level. This alarm as well can be used to drive an audible or visible alarm, which whatever best suits your designs. We've also added a pulse width modulation output to this design. The duty cycle is proportional to the CO2 level that the sensor's measuring. We've also done it in 3 different modes, so it can be off, it can be on continuously, or you can have different pulses for it. So if you want to add some additional circuitry that you can see in the diagram there, you can have a very low cost analog CO2 level output for the sensor. So again, that's something that you may want to, or your customer may have requested. And with the pulse mode, it offers the low output option for you. Okay, let's move on to some of the software functions. Now, pressure. When we calibrate all our sensors, we calibrate them at 1013 millibar. Now, you may have customers who are deploying these sensors in skyscrapers, or they may be in cities that are up at altitude where you may want to do some pressure compensation for it. If you think about it, the lower down, the more pressure there is, the more molecules are together, the greater the absorptions of CO2 is going to be. So if you're up at a higher level, there's going to be more spacing in the molecule, so there's going to be less absorption, so you have to make some adjustment for it. In your system, if you can get a pressure setting, you can feed that pressure setting into the sensor. In our sensors, we hold tables there, so once you put that setting in once, all subsequent readings for it will be compensated at that pressure. Okay, so this ensures that you've got an accurate CO2 measurement regardless of the environmental conditions. Okay. 0 setting. All NDIR sensors need a 0 setting. We recommend that when you get sensors and you build it into a product, that you carry out a 0. 1, to remove any mechanical stress that the sensor may have had, or any flux fumes that may have gotten into the sensor during the manufacturing process. And then again, when you install a sensor, again, we recommend that a 0 is done on the sensor just to make sure everything's back where it should be. Now, you can, please feel free to get in touch to discuss the zeroing strategy with you. I'm going to come on and talk about auto-zeroing on the next slide. But you can 0 in different ways. You can use a known gas concentration. So you flow the known gas onto the sensor, allow it to stabilize, and then you can set it at that. You can use nitrogen as your known gas, so it would obviously be a 0 CO2 reading, or you can use fresh air, which is typically 400 to 413 ppm. I want to talk about auto-zeroing settings. In the little graph that you can see on the right-hand side, this is a measurement of a sensor over a period of time. And as you can see, as people go in and out the buildings, the CO2 levels go up and down and go up and down and go up and down. It's taken over an 8-day period, as the logic behind this is if it's in a building, if the building isn't used all the time, over an 8-day period, the assumption is that the building is going to be empty. So it would take the lowest reading it takes over that time. It would then make the assumption that that's ambient CO2, and it would use that to re-zero the sensor. Now, we know that in some new modern buildings, the insulation is that good, that there's no drafts, and the occupation of the building may be such that it's used most of the time and most of the day, that it never gets down to a 400 level. But if you know the level that it does get down to, maybe say 800 when the night shift's on, you can program the sensor to use 800 as that value. So this function is fully programmable, and it's in there to ensure that you don't have to go round and recalibrate every so often. So very useful. If you're not sure of it, please drop us an email and we can set up a Teams meeting to discuss through this, and also your installation strategy. What you can do when you set it up for your installation strategy is to install the product, do 0 after a day, and then revert back to an 8-day period. We're happy to go through all this with you. We know it's a bit complicated to get your head round, but please get in touch and we can go through that with you. Okay, some other settings that we think are useful in the sensor is that we've added a self-test routine. This has come from developments that we had in the avionics, the aerospace market, that we've put a self-check routine to validate the sensor is operating. And if it's not operating, it sends up an error. So it's a good automatic health check that you can use as part of your installation in the field to make sure that once you put the sensor there, everything's okay. Measurement of the sensor, this is programmable. You can program how often you want it to measure and for how long. This kind of comes down to what your power budget is with the rest of your system. But you can put the sensor into sleep mode. We're happy to talk through different power modes and things with you. In fact, one of my colleagues has done another webinar that you'll get the link to on our website that's well with a watch if you want to look at that from the power side of it. We've also added an hours function to our sensors, so you can read how long the sensor has been powered up. So it allows you to manage the lifetime of the sensor, or it could be another revenue stream for you. You could agree with your end customer that after so many hours of operation that you should come in and do a service. That's up to you. Don't know. That's part of maybe a business offering you can discuss with your end clients. But that option is there, so we think that's a useful one to add in. Power consumption figures. In the table below, you can see the different states of the sensor and how much power that's drawing there. So, and the control can be done either with a software interface or with the hardware via the power on pin that I mentioned earlier. And again, I would recommend that you watch Mark's webinar on the power consumption. So a quick summary of the LP3, has a low height profile, so it's ideal for space constraint applications. It has ultra low power consumption, so ideal for battery powered applications or energy harvesting applications. We've added an alarm level flag, which you can use or not use. So it's a fail safe if you need to, if your clients want a fail safe in there as well. We've added a pulse width modulation output that can give you a low-cost analog output, again, if that's useful for you. There is pressure compensation within the sensor, so you can automatically adjust it for altitude, which may help with your deployment in various cities. And we've put a self-test in there to give you an automatic health check on the sensor. So that's the summary of the LP3. Here are the contact details for myself and for my colleagues. Please feel free to email us, call us, set up Teams meetings to discuss anything we may have covered today. If you have new legislation that's coming out that you want to discuss with us, again, drop us a note. And if there's anything else, please feel free to drop us a note. I look forward to when we can get back out and come and meet you face to face. In In the meantime, we're here on Teams. We're still producing lots of sensors. We have lots of people looking at various things, COVID-related and ventilation-related, so we think there's a good market for these sensors there. So I'd like to thank you again for your time, and stay safe and take care. Thank you.